solving a system of linear equations using the substitution method. This is one of the methods using algebra. We've already learned how to graph a system of equations to look at the solution. So now let's take a look at how we can use algebra to speed up the process a little bit. So here I've given you a very easy example of a system. Okay, and what we're going to do here is we're going to take one of the equations and we're going to literally plug it in or substitute it into the other one. Now, in order to do this, what I need is I need one of my variables in either of the equations. It doesn't matter which one. I need one of them to already have a coefficient of 1 or to be solved for already. And once I have that, you notice right here the y is already solved for it. Once I have that, then I can take the rest of the equation and I can substitute it into the other equation. Okay, so y equals 2x, so that means over here I can take out the y, I can substitute in the 2x. Now that I have an equation that only has one variable, I can solve it like normal. 1x plus 2x equals 3x, and then I can divide both sides by 3, and I can figure out that in this system, x is equal to 2. Now, I'm not done yet. I need to find the value for y. So what I'll do is I'll take this answer and I'll substitute it back into the original equation. So y equals 2 times the value of x. The value of x is 2, so y equals 2 times 2. Therefore, y equals 4. Put that all together, and our solution to this system is 2, 4. So let's take a look at what we've already learned. In the previous lesson, we learned about the graphic method. And in the graphic method, we talked about having to take each of the equations, get them set up so you can graph them. For some of them, that's going to be really easy. Just go ahead and list your slope and your y-intercept. Go ahead and graph those things. For the second equation, we're going to have to flip it into y equals mx plus b before we can graph it there. Then we'll go ahead and list our parts and graph it. Now, yesterday when we talked about the graphing method, everything kind of worked out really good, and we talked about the intersection of the two lines being the solution. But as you can see in this example, the intersection of the two lines doesn't lie exactly on a point. So then it would be up to us to estimate or kind of try to figure out about what that answer is. Unfortunately, when we're solving equations, we don't want to know approximately what the answer is. We want to know exactly what the answer is. So when you look at substitution, we can substitute one of them into the other. Okay, we can do our simplifying of the left-hand side, combine your like terms, start solving, and now we get a more precise answer. Okay, x is equal to 3.75. Take that, plug it into the other one. Y equals the x value, take away 1, so 3 and 75 hundredths minus 1 is 2 and 75 hundredths, for a final answer of 3 and 75 hundredths, comma 2 and 75 hundredths. So as you can see here, the graphic method, although it's pretty easy to do, will sometimes give you an answer that's not very precise, and you're left with having to estimate or kind of guess about how much your answer is going to be. Unfortunately, that's not going to be acceptable for these type of problems. They're going to want to know exactly what the answer is. So by using algebra, or the substitution method, every single time you do the problem, you'll find exactly what the answer is, without a doubt. No guessing, no estimation, or anything like that. So if you have a graph, go ahead and do the graphing method. But if you just have equations, the algebraic methods are going to be the ones that you're going to want to use the most, because they will always give you the exact answer. So let's try another one. Looking at this one, we have our two equations, and we want to look for a variable that's already solved or has a coefficient of 1. So if I take these equations and I put them side by side, I'll notice that in the first equation, I already have x by itself. Now, I don't really know what x is equal to. All I know is that x is equal to 3 times whatever y is. So now I can use that to my advantage, and I can take that 3y over to the other equation, and I can say, well, if x is equal to 3y, then over in the other equation, 4 times x is going to be the same as saying 4 times 3y. That eliminates my problem of having two different variables in my equation, and it gives me only one variable, and now I can use our normal equation solving methods to get this done. So I'll go ahead and multiply the 4 and the 3, then I'll combine my y's, and now I'll solve. So now we can know that y is equal to negative 1/2. Now remember, in order to get the answer to a system, you have to have both the x and the y value. So now take the y value and plug it in to the original equation. 3 times y. So now x is equal to 3 times y, which we figured out is negative 1/2. So 3 times negative 1/2 is equal to negative 3 over 2. Take your answer, arrange them correctly in an ordered pair, and you'll know that the solution to this system is negative 3 over 2, comma, negative 1 over 2. If you need to check your answer, you can go ahead and plug those values back in, and you will see that they equal each other. In this equation, you'll notice that we're going to have to do a little fixing before we can solve things here. If you take a look at our two equations this time, you'll notice that although we have a variable that doesn't have a coefficient on it, or a coefficient of 1, we don't have a variable that's actually set equal to anything. So now we're going to have to use some of the skills that we've learned before, and we're going to have to rearrange this equation. So what I'm going to do is in the first equation, I'm going to take that 2y and I'm going to move it to the other side, and then my x will be isolated. Once my x is isolated, now I know what it's equal to. X is equal to negative 2 times y plus 5. I'll take that and I'm going to plug it in behind the 2 here. Now it's really important that when you plug this in, you take consideration the x already has a coefficient. So you need to plug it in using parentheses, and we're going to have to do a little distributive property. Go ahead and distribute this. After that, go ahead and combine your like terms, and now you can solve. Now, remember, like we talked about before, negative y is equal to negative 3. So you're going to need to multiply that by negative 1, so you can get the true answer of y equals 3. Now, just like we did in the other examples, we're going to take our answer and plug it back into our first equation. X is equal to negative 2 times y plus 5. So x is equal to negative 2 times 3 plus 5. And then you can just evaluate that and get your answer. Put them all together, and the answer to this system is negative 1, comma 3. If you want to check, we can plug those in. Take it up to the top. 2 times 3 is 6, plus negative 1 is 5. Doing the second equation, 2 times negative 1 is negative 2. 3 times 3 is 9. Negative 2 plus 9 equals 7. Here's one I'd like you to try yourself. Take a second and pause the video, work the problem, and then come back and check the solution. Alright, cool. Here's what you did. Hopefully you did it right. Let's take a check. First of all, I'm going to look at both of these equations, and I'm going to look for the variable that has no coefficient on it that I can easily set equal to 0, or set equal to the other side, excuse me. I'm going to focus on the second equation, looking at negative y, and I'm going to isolate it. Now hopefully you remembered that negative y isn't going to work for us, and then we need to multiply everything. Now once I get that, I can plug it into my other one. Remember to use parentheses and use the distributive property. Distribute. Combine like terms. Solve. And we get x is equal to 29 over 11. I'm sure a few of you probably thought that you were absolutely wrong with that answer. I know sometimes I feel the same way when I do math problems, but 29 over 11 is perfectly fine. Now we're going to take that and we're going to plug it into the other equation, just like we did in the other examples. We're going to say y is equal to 2 times 29 over 11 minus 6. Now remember here, I'm just going to multiply 2 times 29 and get 58 over 11. And now I'm going to take 6 and I'm going to make it 6 over 1 and then convert it to a fraction with the same denominator. That'll make it 66 over 11. And then we'll subtract the numerators and get negative 8/11 for a final answer of 29 over 11, comma, negative 8 over 11. Let's take a look at how we can use this in a real-world problem using something like a cell phone fee here. So in this problem, it says that Chatty Phone charges a flat monthly fee of $20 plus 8 cents a minute. Telco charges $14 plus 10 cents a minute. When will the two charges be the same? So, like we saw before when we did linear equation word problems, we need to figure out the initial value and then the rate of change. But this time we have, instead of just one company, we have two companies. So then obviously we'll just do it for both companies. Let's let X be the number of minutes that we talk, and Y will be the total cost. Looking at Chatty Phone, they charge $20 fee plus 8 cents a minute. So 20 plus 0.08 times X, just like we learned in the last unit. Now Telco is a little bit different. They do $14 plus 10 cents a minute. So they'll be Y equals 14 plus 0.10X. Now what I'm going to do is instead of graphing them, I'm going to substitute them. So I'm going to pick one of them. If you notice, both equations are already equal to y. So I can literally pick either one I want and plug it into the other one. So I'll just take the first one and I'm going to plug it right here on the end. And then what's going to happen is we're going to get a familiar equation that we've seen in the past. We're going to get a one variable equation with variables on both sides. And now we can just start solving. I'm going to collect my x's on one side. Now I'm going to collect my constants on the other side. And then I'll divide. So x equals 300 minutes. Now, since the question was just when do they charge the same, I don't really need to figure out the total cost because they're not asking. So I can skip the part of plugging the 300 back into the equation, and I can just get my final answer of at 300 minutes, they charge the same. I hope this was helpful in explaining what we learned today in class. Please feel free to watch it as many times as you need to, remembering to pause and start and restart whenever you need to in order to understand everything. Have a great day, boys and girls.